In the contemporary landscape of human resource management, (HRM), and talent acquisition, the integration of data analytics has emerged as a transformative force, revolutionizing traditional practices and decision-making processes. While we will learn about data-based decision-making later, let us focus on the use and applications of data analytics in human resource management and talent acquisition. In the contemporary landscape of human resource management, (HRM), and talent acquisition, the integration of data analytics has emerged as a transformative force, revolutionizing traditional practices and decision-making processes. While we will learn about data-based decision-making later, let us focus on the use and applications of data analytics in human resource management and talent acquisition. You will learn to use a wide variety of data for planning and decision-making purposes, begin to develop abilities to use data to describe program operations and/or practices, observe basic techniques of data analysis to real-life examples, and identify and articulate trends and patterns in data gathered over time. At the end of this course, you will have a complete understanding of data analysis as well as your own ideas of what and how you can practice it. To make sense of the way we use terms for analytics in HR, let us see the terms and understand the differences among them. In many contexts, the differences do not matter, but when they do matter, a lack of understanding can lead a project team astray. Workforce analytics focuses on workforce metrics and optimization, applying statistical models, worker-related data to optimize human resource management. Techopedia. In a general sense, it relates to the size and shape of the workforce. People analytics originated with the Google approach to making people management decisions, Sullivan. A radical departure from the subjective approach to managing people decisions, it infers application of the same rigor used in engineering decisions to people decisions. Talent analytics means anything from using data to manage the workforce to planning a single career, depending on the source. Bersin defines it as the use of measurement and analysis techniques to understand, improve, and optimize the people side of business, and conflates it with big data and people analytics. 5. Merriam-Webster defines talent as the natural endowments of a person or a group of individuals. Those attributes are what drive the competitive advantage people bring to an organization. Human resource analytics is the application of analytics to HR processes to improve employee performance and return on investment, Techopedia. In its strictest sense, it focuses on how well the HR organization provides services, with the ultimate output being performance and productivity. To start with, let us understand the approach. For this, we will use the LAMP framework. The LAMP framework is a structured approach to HR analytics that helps organizations make data-driven decisions. These are 4 critical components of a measurement system that drives strategic change and organizational effectiveness. Measures represent only one component of this system. Although they are essential, without the other 3 components, the measures and data are destined to remain isolated from the true purpose of HR management systems. We will understand each of these one by one. Overall, the LAMP framework is a valuable tool for HR professionals who want to leverage data to drive business success. By following this framework, HR can become a strategic partner to the business and help the organization achieve its goals. Without proper logic, it is impossible to know where to look for insights. The logic element of any measurement system provides the story behind the connections between the numbers and the effects and outcomes. Without proper logic, it is impossible to know where to look for insights. The logic element of any measurement system provides the story behind the connections between the numbers and the effects and outcomes. In this book, we provide logical models that help to organize the measurements and show how they inform better decisions. Now let's talk about data. By closely examining data, we can find patterns to perceive information, and then information can be used to enhance knowledge. Data patterns reveal insights, enabling informed decisions, innovation, and optimization. However, on the downside, misinterpreting patterns leads to flawed conclusions and biases. HR data, especially when used along with HR analytics, can provide valuable insights into your workforce. It can reveal trends, patterns, and correlations that will help you make better business decisions. Let's look at a quick example. A company experiences high voluntary turnover rates. They start looking at data related to this issue, such as if you will notice L2 and L3 levels show high level of leaving. So let's drill into that, with a focus on Team A. We need to understand whether it was a boss problem, performance pressure, geography, skill set. Quantitative data are the value of data in the form of counts or numbers where each data set has a unique numerical value associated with it, whereas qualitative data are data representing information and concepts that are not represented by numbers. They are often gathered from interviews and focus groups, personal diaries and lab notebooks, maps, photographs, and other printed materials or observations. What is obvious from the example of the screen is that for a decision to be made based on data, while qualitative data provides the means by which analysts can quantify the world around them. For a high-quality decision, both are usually required. An example of this is an opinion poll. To the person interviewed, what is collected is qualitative data. But when compiled into percentages, it constitutes quantitative data. An example of this is an opinion poll. To the person interviewed, what is collected is qualitative data. But when compiled and interpreted into percentages, it constitutes quantitative data. Now you can see how it works. The green states the decision. However, that poll was held in one state while the country has 15 states, all with their own regional languages. Is it still a good decision? HR data is essential for any company that wants to leverage the power of its employees and start making data-driven decisions. Along with people analytics or HR analytics, HR data can help you spot trends and patterns and make predictions about future events. Like any scientific discipline, data analysis follows a rigorous step-by-step process. Each stage requires different skills and know-how. To get meaningful insights, though, it's important to understand the process as a whole. An underlying framework is invaluable for producing results that stand up to scrutiny. An effective data analysis process is based upon the nature and mission of the organization as well as upon the skills of the team that is charged with the task of collecting and using data for program purposes. Above all, an effective data analysis process is functional, i.e., it is useful and adds value to organizational services and individual practices. In some cases, the data analysis process can even be regarded as fun. We have already discussed that data analysis is a process involving 5 steps. When we consider the first step and define the question, we need to remember that the question has to be relevant, meaning it should be specific to the objective or purpose of that exercise. If you want to gather data on how hot the weather is, you are not going to ask if the responder sleeps at night. You have to ask the right question to get an answer that fulfills the purpose. Asking the question and recording the answer is step 2. In step 3, we need to scrub the data and clean it so that there are no errors. For example, if someone has written or answered that weather is 75 degrees centigrade, you know that is not true. But if you retain that data, it will skew the results and create a false narrative. Only after this are we ready to analyze the data, according to a predetermined strategy and share the results. We will now borrow from the experts. Here we quote Migrant and Seasonal Head Start Technical Assistance Center Academy for Educational Development contract with DHHS, ACF, OS, Migrant and Seasonal Program Branch. There are a variety of strategies for quantitative and qualitative analyses, many of which go well beyond the scope of an introductory handbook. Different strategies provide data analysts with an organized approach to working with data. They enable the analyst to create a logical sequence for the use of different procedures. In the next screen, you will see 4 examples of strategies for quantitative analysis, which are more or less a standard format, and which you will probably use in your work. There can be different ones as well, depending on the kind of answers sought. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. Additionally, it provides an excellent way for employees or business owners to present data to non-technical audiences without confusion. In the world of big data, data visualization tools and technologies are essential to analyze massive amounts of information and make data-driven decisions. If you have ever seen a spreadsheet with massive amounts of data, so much data that you could not make head or tail of it, that is where data visualization plays a part by putting that data in forms that are relevant and understandable. Technically, it is not analysis, nor is it a substitute for analysis. However, visualizing data can be a useful starting point prior to the analysis of data. Exploratory data analysis, EDA, is an analysis approach that identifies general patterns in the data. These patterns include outliers and features of the data that might be unexpected. EDA is an important first step in any data analysis. It involves looking at data to identify or describe what's going on. It is creating an initial starting point, baseline, for future analysis. Exploratory data analysis, EDA, is important for several reasons, especially in the context of data science and statistical modeling. Here are some of the key reasons why EDA is a critical step in the data analysis process. Understanding data structures. EDA helps in getting familiar with the dataset, understanding the number of features, the type of data in each feature, and the distribution of data points. This understanding is crucial for selecting appropriate analysis or prediction techniques. Identifying patterns and relationships. Through visualizations and statistical summaries, EDA can reveal hidden patterns and intrinsic relationships between variables. These insights can guide further analysis and enable more effective feature engineering and model building. Detecting anomalies and outliers. EDA is essential for identifying errors or unusual data points that may adversely affect the results of your analysis. Detecting these early can prevent costly mistakes in predictive modeling and analysis. Testing assumptions. Many statistical models assume that data follow a certain distribution or that variables are independent. EDA involves checking these assumptions. If the assumptions do not hold, the conclusions drawn from the model could be invalid. Informing feature selection and engineering. Insights gained from EDA can inform which features are most relevant to include in a model and how to transform them, scaling, encoding, to improve model performance. Optimizing model design. By understanding the data's characteristics, analysts can choose appropriate modeling techniques, decide on the complexity of the model, and better tune model parameters. Facilitating data cleaning. EDA helps in spotting missing values and errors in the data, which are critical to address before further analysis to improve data quality and integrity. Enhancing communication. Visual and statistical summaries from EDA can make it easier to communicate findings and convince others of the validity of your conclusions, particularly when explaining data-driven insights to stakeholders without technical backgrounds. EDA, or exploratory data analysis, refers back to the method of analyzing information units to uncover styles, pick out relationships, and gain insights. There are various sorts of EDA strategies that can be hired relying on the nature of the records and the desires of the evaluation. Depending on the number of columns we are analyzing, we can divide EDA into three types: univariate, bivariate, and multivariate. Trend analysis is defined as a statistical and analytical technique used to evaluate and identify patterns, trends, or changes in data over time. It involves the examination of historical data to uncover insights into the direction or tendencies of a particular phenomenon. It is a technique which can be used to predict future outcomes based on past and present data. For example, stock price movements. Other uses are to understand and predict customer trends, seasonality, social media trends, etc. Estimation is another data analysis strategy. It involves using actual data values to predict a future value. Estimation is the process by which the numerical value of unknown population values are inferred from incomplete data, such as a sample. If a single figure is calculated for each unknown parameter, the process is called point estimation. Now that we have cleaned our data, now comes the fun bit, analyzing it. The type of data analysis you carry out largely depends on what your goal is. But there are many techniques available. Univariate or bivariate analysis, time series analysis, and regression analysis are just a few you might have heard of. More important than the different types, though, is how you apply them. This depends on what insights you're hoping to gain. Broadly speaking, all types of data analysis fit into one of the following four categories. Descriptive analysis identifies what has already happened. It is a common first step that companies carry out before proceeding with deeper explorations. As an example, let's refer back to our fictional learning provider once more. Top-Notch Learning might use descriptive analytics to analyze course completion rates for their customers. Or they might identify how many users access their products during a particular period. Perhaps they'll use it to measure sales figures over the last 5 years. While the company might not draw firm conclusions from any of these insights, summarizing and describing the data will help them to determine how to proceed. Diagnostic analytics focuses on understanding why something has happened. It is literally the diagnosis of a problem, just as a doctor uses a patient's symptoms to diagnose a disease. Predictive analysis allows you to identify future trends based on historical data. In business, predictive analysis is commonly used to forecast future growth, for example. But it doesn't stop there. Predictive analysis has grown increasingly sophisticated in recent years. The speedy evolution of machine learning allows organizations to make surprisingly accurate forecasts. Take the insurance industry. Insurance providers commonly use past data to predict which customer groups are more likely to get into accidents. As a result, they'll hike up customer insurance premiums for those groups. Likewise, the retail industry often uses transaction data to predict where future trends lie, or to determine seasonal buying habits to inform their strategies. These are just a few simple examples, but the untapped potential of predictive analysis is pretty compelling. Predictive analytics in HR involves using historical data to forecast future outcomes related to human capital. By leveraging advanced statistical techniques and machine learning algorithms, HR teams can make informed decisions that drive business success. As usual, there are some challenges and considerations to keep in mind as we leverage data. First is data quality, where we need to ensure data accuracy and completeness, which is crucial for reliable predictions. Model complexity. Developing and maintaining complex predictive models requires specialized expertise. Ethical considerations. Using employee data ethically and responsibly is essential. Change management. Implementing predictive analytics requires a cultural shift and buy-in from HR and business leaders. By leveraging predictive analytics, HR teams can make more informed decisions, improve employee satisfaction, and drive business performance. It's important to remember that while predictive analytics is a powerful tool, it should be used in conjunction with human judgment and intuition. Prescriptive analysis allows you to make recommendations for the future. This is the final step in the analytics part of the process. It's also the most complex. This is because it incorporates aspects of all the other analyses we've described. A great example of prescriptive analytics is the algorithms that guide Google's self-driving cars. Every second, these algorithms make countless decisions based on past and present data, ensuring a smooth, safe ride. Prescriptive analytics also helps companies decide on new products or areas of business to invest in. Technology and data analytics offer a huge opportunity for HR teams to improve their organizational processes. For example, using real-time data can help HR teams optimize recruitment and onboarding tasks, streamline their workflows, and boost employee engagement. Here we have put together some advisories on leveraging HR data by Forbes Council members. These main steps of data analytics process, and they can be amended, reordered and reused as you deem fit, but they underpin every data analyst's work. Define the question. What business problem are you trying to solve? Frame it as a question to help you focus on finding a clear answer. Collect data. Create a strategy for collecting data. Which data sources are most likely to help you solve your business problem? Clean the data. Explore, scrub, tidy, dedupe, and structure your data as needed. Do whatever you have to. But don't rush, take your time. Analyze the data. Carry out various analyses to obtain insights. Focus on the 4 types of data analysis: descriptive, diagnostic, predictive, and prescriptive. Share your results. How best can you share your insights and recommendations? A combination of visualization tools and communication is key. What next? From here, we strongly encourage you to skills you will need. In the next video, we have covered a very important topic, using Excel as a data analysis tool. This is where you will learn to actually do data analytics. Get creative with the steps in the data analysis process, and see what tools you can find. As long as you stick to the core principles we've described, you can also create a tailored technique that works for you.